Good morning, everyone. Today we are going to learn about energy and power signals. Energy So, in order for you to find the energy of a signal, you have to use E equals to minus infinite to infinite mod of xt square dt for a continuous time signal. For continuous time. And E equals to summation n equals to minus infinite to infinite mod of xn square for discrete time signal. Now, for a signal to be an energy signal, for a signal to be an energy signal, it must satisfy this condition, whether it's a continuous time domain signal or it's a discrete time domain signal, that the energy must be finite, or you can say it lies between 0 to infinite. Then it is an energy signal. So let's take an example of it. So if we have xt equals to e raised to the power minus t ut. So you must know that ut is defined from 0 to infinite. So e will be, the limits of the integration will become from 0 to infinite. Why? Due to this ut. Ut has an amplitude equals to 1 for t greater than equals to 0. You can say from 0 to infinite. So we will have this. So we can then, what left is e raised to the power minus t. So e raised to the power mod is again same, and square dt, or you can write it as 0 to infinite e raised to the power minus 2t dt. Now integrate it with respect to t. So e will be equals to e raised to the power minus 2t divided by minus t minus 2, and the limits of integration are from 0 to infinite. So it will be equals to e raised to the power minus infinite minus e raised to the power 0 for minus 2, and so it will be 1 by 2. So 1 by 2 we can say it lies between this. So it's an energy signal. Let's take another example where we have xt is equals to e raised to the power minus jt ut. Again here the limits of integration remain same, so it will be from 0 to infinite. So what's left is e raised to the power minus jt mod square dt. Remember, you are not going to open the square, you have to take the mod first and then you will square it. So if you remember, what's the mod of e raised to the power j theta? E raised to the power j theta is basically equals to cos theta plus j sin theta, and when we will take the mod of a complex number, it will be under root of your real part square plus imaginary part. So it will be cos square theta plus sine square theta, or you can say it's equals to 1. So the E equals to here from 0 to infinite 1 dt, or you can say it is t for 0 to infinite. So answer is infinite. So the energy is infinite, therefore it is not an energy signal. So what happens if the signal is not an energy signal? We check whether the signal is a power signal or not. So how to find the power? So power signal, the formula used to find the power of the signal will be using this. The formula is, you know that energy divided by time is power. In a similar way, in signals also we find power equals to P equals to, denoted by P, limit t tends to infinite. You take average over the time period about which you are integrating. So it's minus t by 2 to t by 2 mod of xt square dt. If you compare it with the formula of energy, the difference is that it's minus infinite to infinite at these 2 points, and you don't see this part here. Okay. And in a similar way, in discrete time domain, it is equals to, if I say denote by n for discrete time domain, it is equals to limit n tends to infinite 1 upon 2n plus 1 summation n equals to minus n to n mod of xn square. Here there is one important thing which you have to notice, that another thing which I need to tell now again to you is that instead of this t by 2 to t by 2, you can use from here, you can use minus t to t, then in place of this you have to write 2t. So here in discrete time domain, what we are doing is, we are basically adding them from minus n to n. So the total number of points, you have to divide the power. In order to find the power, you have to divide the energy by total number of points which you are adding to find the power of the signal. So the total number of points are here are from minus n to n. So generally people will think that minus n to n means n terms here, and you need to you'll think that you have to write here 2n. But you have to consider that from minus n to n, if I plot it like this, so this is my minus n, let's say this is n, there is a 0 also. So n points on negative sides and n point on positive sides. So total number of points are 2n plus 1. If you don't understand, I'm taking another example. Just count how many points you have from minus 2 to 2. So the points are minus 2, minus 1, 0, 1 and 2. So total number of points are 5. So they are basically twice of 2, means 2n plus 1, which is due to this 0 here. Hope you understand this. So if the signal is a power signal, then the power is between 0p less than infinite, or you can say power is finite. Okay. An example of this is, let's take is x of t equals to sine 2 pi f t. So p will be equals to limit t tends to infinite 1 upon t, t is your basically time period, minus t by 2 to t by 2 and sine 2 pi f t square dt. So if you remember that sine square theta is equals to 1 minus cos 2 theta divided by 2. Here this is square and this is twice. Okay, put this thing in your integration. So it's p equals to limit t tends to infinite 1 upon t minus, you can use t by to t minus t to t, so it's up to you. Then it will be 1 minus cos 2 theta, so theta is your 2 pi ft, so it will be 4 pi f t divided by 2 dt. So when you will integrate it, it will be limit t tends to infinite 1 upon t, this 2 will come outside here, so it will be t minus sine 4 pi t divided by here 4 pi f t, t by 2 to minus t by 2. So when you put the limits of integration, it will be limit t tends to infinite 1 upon 2t, put the upper limits and lower limit, so it will be t by 2 minus and then minus, when you will put here it will be sine 4 pi f t by 2, sorry, just mind with the small space here, it will be sine theta, sine of minus theta is sine of theta, so it will become plus sine 4 pi f t by 2. Now the another important thing which we need to do here is equals to your if you know that or not, that frequency is inversely proportional to time, or you can say omega t is equals to 2 pi, or you can say 2 pi f t is equals to 2 pi or f is, as I started, inversely proportional to this. So when you have f and t, when you have f and t, they can be replaced by this f and t can be replaced by 1, and then if f into t is equals to equals to 1, so you can say sine of 4 pi t divided by 2 is equals to sine 2 pi, and sine of 2 pi is equals to 0. So you can say this part and this part is equals to 0. So the only thing which is left is for us is the only thing which is left for us as power is limit t tends to infinite 1 upon 2t into t. So when you will do it, they will cancel each other. So then it will be equals to 1 by 2. So you can say the power is between this. So it's a power signal. Let me take an example for a discrete time domain also. So if we have in a similar pattern, suppose we have a signal like x of n equals to 1 by 2 raised to the power n un, and you want to find the whether it's an energy signal or power signal. So you will use E equals to summation n equals to minus infinite to infinite always start with writing your formula to find the energy. So then you can say that un is defined from, I'm going to upload a separate video for defining these important signals, unit step, impulse functions, and all these important functions which we are going to use in this course. So as un is defined from n equals to 0 to infinite, so the limit of summation changes to 0 to infinite, and the mode is 1 by 2 raised to the power n whole square. So it will be summation n equals to 0 to infinite 1 upon 4 raised to the power n. So if you are familiar with your algebra, you can see that this is an infinite GP. What is GP? GP is your geometric progression. So if you remember, for a geometric progression of infinite numbers, the sum of it is equals to a upon 1 minus r, where a is the first number in GP and r is its common ratio. So for this, the first number means n equals to 0. So for our case, a is equals to, when you put n equals to 0 in this, and you will put in this, n equals to 0. So it will be 1 by 4 raised to the power 0, it's equals to 1. So in order to find the r common ratio, you need to find your second number. So second number is when you will put n equals to 1. So your second number, or your second number of GP is equals to n equals to 1. So it will be 1 by 4. So your r, the common ratio, will be equals to second number divided by first number. So in this case it will be equals to 1 by 4 divided by 1 equals to 1 by 4. So now the E will be then equals to A is 1 minus 1 by 4. So it will be equals to 4 by 3. So you can say 0 less E less infinite. So it's an energy signal. Now at this point I want to give you some work. So I want you to try when you have x of n equals to minus jn un, and please write your answers in the comment box, and please like, share and subscribe this channel for me to upload more videos on the same course. Thank you.